Morning class, this is Mr. Lee. This is Wednesday's November 5th. This is the video for today. We have a short schedule. I'm going to cover the rest of the packet starting at problem 3. Yesterday on the Tuesday video, you finished up with problem number 2 all the way to C. Let's finish up with part D. Is the relationship between the cost and the number of toppings proportional or non-proportional? If you guys remember, yesterday we knew that this was 8 plus 0.48t. Now, we want to figure if it's proportional or non-proportional. So, is it proportional or non-proportional? Well, we need to figure out if it starts at 0. So let's make a chart. And it's going to be with the letter C and the letter T. So if T is 0, what would C be? Right now, I want you to try to figure out what would happen if we inputted a 0 for the t. What would our cost be? All right, welcome back. I gave you guys a couple of seconds to think it out. Well, think about this. How much do we have to pay for each topping? It's 48 cents. What happens if we have 0 toppings? So it'll be 8 plus 0.48 times 0. That'll be 8 plus 0. That equals 8. So instead of a question mark, I'd get 8. So the answer is it's non-proportional because the pizza will always be cost $8 even if we get 0 toppings. So that's what it means. All right. Make sure you get it down. Let's go to the next page. All right. This right here was based off Tuesday's bell work. Part E. So Tani ordered cheese pizza from Mega Topping. It cost $13.28. How many toppings did she order? We have to show our calculations. We know using ACE that the answer is going to be 11. You already have the answer on the front page of your Cornell notes. So the answer, it's going to be 11. Now, let's show our computation. And the computation is going to be different. So our computation it's going to look like this. We have $13.28. And what do we have to subtract it from? How much is each pizza? Each pizza is what? We know if we look back, it's going to be $8. So it'll be $13.28 minus 8. So I want you guys to subtract that for me right now. Do $13.28 minus $8. Pause it right here and do this right now. All right, again, do this right now, subtract it. Welcome back. Here's the answer. The answer when you subtract it is $5.28. But now, what do we have to do? We have to figure out how many toppings. What's the cost of toppings? The cost of toppings is what? For one topping is 48 cents. So right now, I want you guys to set up this division house. Your division house is going to look like this. It's going to be $5.28 divided by 48 cents. And I need you guys to do this one now. So pause the video and try to do it. In a couple more seconds, you can unpause the video and check your answer. Welcome back. Here, let's check your answer. So on the outside, it's going to be 48 cents. And I don't know my 48 times tables, so even before I float this guy up, I have to jump him. So I jump him 1, 2. What I do outside, I do inside. So it's 1, 2. So this floats up right here. Now I have to say 48 times what will get me close to 52. So I know it's going to be 48 times 1. That's going to get me 48. 48 times 1 gets me 48. So I put it right here, and now I subtract. I have to borrow because 2 can't subtract 8, so this becomes 4. 12 minus 8 gets me 48. 48 goes into 48. Well, that goes in there one time. So how many toppings? It's going to be 11 toppings. So $13 minus 28, and then I want you to show the division. So it's going to be $5.28 divided by 48 cents. All right. So let's go on to part F. Which of these graphs shows the relationship between the number of toppings and the C? Explain how you figured it out. So we're going to do some explanation. Now, let's go back. Is our graph proportional or non-proportional? If we look back, it's non-proportional. So I want you guys to underline non-proportional. That means no 0, 0. No 0, 0. That means it can't be this one. And it has to start, let's see where it starts at. It has to have an 8. So if we go back, this is our X and this is our Y. So let's look at this. This is our y, this is our x, this is our y, and this is our x, and this is our y, and this is our x. And we know x equals 0 and y equals 8. So know this one. So it's either this one or this one. Which one can it be? It has to be graph number 3. So it's going to be graph 3. So here's what we're going to write. We're going to write graph 3. Graph 3 because it starts at 0 toppings and has a cost of $8. And the line goes straight, which means it's a steady increase of 48 cents for each topping. What I mean by that is this. You see how graph number 3 has this straight line? So because it has a straight line, that tells me each topping will always get 48 cents. This line right here, it means the first 4 or 5 toppings are always like topping number 2 and 3 will always have like $8. Then all of a sudden after topping number 2 or 3, it goes up to 48 cents. So this is a no. All right. For problem number 3, Jake makes staircases of toothpicks and arranges it in a square. So we're doing another pattern problem. He counts the number of toothpicks and uses it to make a table to show his findings. All right. So we've got staircase 1, staircase 2, staircase 3, staircase 4. So it's 1, 2, 3, and 4. How many toothpicks is the perimeter of staircase 17? So we want all the way to staircase 17. So we want number 17. Explain your reasoning. So let's try to figure out a pattern. So let me we want staircase 17. Here we go. And we need to explain. All right, so here's what I'm going to do. I'm going to make a table. And it's going to be, I'm going to have my variables be S for the staircase and T for the toothpick. All right. So I have 1, 2, 3, and 4. I'm also going to go all the way down to 17. So for number 1, it's 1, 2, 3, 4. So I have 4 right here. For this one, it's 1, 2, 3, 4, 5, 6, 7, 8. So I have 8. I want you guys to pause this video and count how many are for staircase number 3 and staircase number 4. Welcome back. So staircase number 3 has 12 of them. All right. And staircase number 4 has 16 of them. So we can see our pattern already, right? It's going up by 4. Or you can also say it's being multiplied by 4, because 1 times 4 gets me 4, 2 times 4 gets me 8, 3 times 12 gets me 3 times 4 gets me 12, and 4 times 4 gets me 16. So our constant proportionality it equals times 4. So how do we get the answer from number 1? It's going to be 17 times 4. And that's going to get me 68. Because 4 times 7 is 28. Carry the 2. 4 times 1 is 2. 4 times 1 is 4 plus 2 is 8. So the answer is 68. So for our explanation, 68 toothpicks for each staircase, because we found our constant by counting the perimeter and making a chart. So we got 4 times 17, which equals 68. If you guys can't see it because of the black line, there you go. For everyone else, part B is going to be this. Write an algebraic rule between the staircase number and the perimeter of the staircase. So for us to get the toothpick, we need to figure out what T was. T equals what times what? Well, we know it's T equals 4 times S. Or we could say T equals 4S. And the S equals staircase number, and T equals number of toothpicks. All right, turn the page. Part C is the relationship of the staircase number and the number of toothpicks. Is it proportional or non-proportional? How do we know? So let's make another table. S and T. Remember, our formula was T equals 4S. So we're going to put in 0 right here. So if T equals 4 times 0, T equals 0. So it's 0, 0. So we know our answer is going to be, oh, it's too early in the morning for this. It is proportional, because we can have an input of 0 and get an output of 0. And what's our constant proportionality? Our constant of proportionality functionality is for. All right, on your own, do now. I need you guys to finish up number 4. I need you to finish 4A to 4G. All right, guys, I'll talk to you later. Bye.